Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corn. I'm doing a little bit of shifting around technology components in preparation for our exit from the current apartment. And there's a few things I would love to ask you about concerning the longest cable runs that one can do. If you want to set up your computer so that you don't have the physical computer next to you, I'm talking about desktops, then I'd love to know what the approximate constraints are for various components. In no particular order. Number one is USB. So most USB, well, a lot of the USB stuff that I own is USB-A to USB Type-C. And it's using USB 3 protocol. I'm looking at a optical media drive, not the most common accessory these days, but that's definitely something that I would love to maybe have in a different part of the room because I rarely use it. The second more practical and everyday thing is monitors. So the ones I have at the moment, I have three at my desk. One of them is connected with HDMI and the other is with DVI. So for both of those, what is the longest cable that one can get and have no issues? Is DVI longer? Because I know that the last time I looked into this, I thought the max was something fairly short in the region of 5 meters. But I'm wondering with the modern standards we have, I know that my monitors are very much old. I mentioned that they are somehow miraculously still working. But what is if I were to buy new monitors tomorrow, what would be the modern connectivity and what's the length of that cable? Final constraint to consider is, I'm looking here, a webcam is USB Type A, so it's the same question. And probably, I'm guessing, that everything is going to be moving to USB-C. So the connections, to the extent that we use physical USB connections in the computers of tomorrow and already today, I imagine everything's going to be USB-C to USB-C. I don't have many ports. I don't think I have any USB Type-C ports on my current desktop, but I'm sure that if I were to look for a component, I could definitely add them. Does that add any lengths to the maximum runs you can do? And I think that's just about it, Herman and Corn. If I knew all those things, I'd be able to guess. Oh, one final thing, I guess, talking about electricity supply, and we're talking in the context of desktop planning here. So the way I have my workstation set up is I have a UPS, and then I have what we call here in Israel a Mickey Mouse cable. That's not obviously the official name. I believe the correct name is an IEC C13 to C14 cable. So the one that goes into the power supply unit at the back of the computer, and the other end goes into an outlet on the UPS itself, and that connects you. How long can those runs be? And that is it. So Herman and Corn, let's talk about the maximum cable lengths for various things. If you wanted to set up a computer workstation, whether a desktop or even maybe a laptop, and you wanted to play around with the idea of keeping a very clean workstation, running your things in with cabling and having the computer physically in a different location. And if you did that, you could do some really cool things with wake on LAN and shut on LAN and actually never need to access the physical computer that's just running all these things. Over to you, Herman and Corn.
So Herman, our housemate Daniel, is at it again. He's moving things around in the house, trying to optimize his workspace. And he has this vision of a silent, minimalist desk where the actual computer is tucked away in another room entirely.
Herman Poppleberry here, and I have to say I love that vision. There is something incredibly satisfying about a workstation that is just monitors and peripherals, with all the heat and fan noise from the desktop tower happening somewhere else. But, as Daniel is finding out, the laws of physics and the specifications of modern cables have some very strong opinions about how far you can actually pull that off.
It is the classic struggle between aesthetics and signal integrity. He sent us this prompt asking about the maximum lengths for basically every cable sticking out of a modern PC. USB, HDMI, DVI, even the power cables. And honestly, it is a great question because what worked for a 1080p monitor 10 years ago definitely does not work for a high refresh rate 4K setup today.
Exactly. The more data we try to shove through these copper wires, the shorter the leash gets. It is all about attenuation and timing. As the signal travels, it gets weaker and the timing gets fuzzy. At a certain point, the receiving end just sees noise. So, where should we start? Should we dive into the USB side of things first?
Let us do it. Daniel specifically mentioned USB 3, going from USB-A to USB-C, and he mentioned an optical media drive. He rarely uses it, so he wants it out of sight. What is the limit there for a standard cable?
For a passive USB 3.0 or 3.1 cable, the official specification is actually surprisingly short. You are looking at about 3 meters, which is roughly 10 feet. If you go beyond that with a standard copper cable, the signal degradation usually leads to the device either not being recognized at all or dropping down to USB 2.0 speeds, which would be a nightmare for an optical drive or a fast external hard drive.
3 meters is not much if you're trying to put the computer in a different room. That basically gets you across a large desk and down to the floor. If Daniel wants that drive in a closet or across the hallway, he is going to hit a wall immediately.
Right? And this is where we have to distinguish between passive and active cables. A passive cable is just wire and plastic. An active cable has a little chip inside, usually at one or both ends, that acts as a signal repeater. It takes the weakening signal and boosts it. With active USB cables, you can reliably get to 5 meters or even 10 meters. But even then, you are still dealing with copper, which has its limits.
What about the newer stuff? I know we talked about the USB-C revolution back in episode 77. Has the transition to USB-C changed the distance game for standard peripherals?
It has actually made it harder in some ways. Because USB-C supports much higher data rates, like 10 or 20 gigabits per second, the cables have to be even higher quality. If you want full 10 gigabit speeds on a passive USB-C to USB-C cable, you are often limited to just 1 meter. If you are okay with slower speeds, you can get longer ones, but for Daniel's remote setup, he really needs to look into fiber-optic USB cables.
Fiber optic? That sounds expensive for a disk drive.
It is more expensive than a $5 cable from the corner store for sure, but fiber-optic USB cables convert the electrical signal into light. Light does not suffer from the same attenuation issues as electricity over copper. You can get fiber optic USB 3 cables that are 15, 30, or even 50 meters long. If Daniel is serious about putting the PC in a completely different part of the house, fiber is the only way to ensure his peripherals actually work at full speed.
That is fascinating. So, the limit is not really the protocol, it is the medium. If you use light, you can go as far as you want, within reason. But let us talk about the monitors, because that is the big one. Daniel has 3 monitors. One is HDMI and one is DVI. He is worried about the DVI because it feels like a legacy format. Is he right to be worried?
DVI is an interesting one. It is essentially the grandfather of HDMI. For a single-link DVI cable, which handles resolutions up to 1920 by 1200, you can actually go quite far, maybe 5 meters or 15 feet without any extra help. If you have a high-quality cable, some people push it to 10 meters, but you start seeing what we call sparklies on the screen. Little white pixels flickering because the data is getting corrupted.
I remember those sparklies from our old gaming setups. It looks like digital snow. What about dual-link DVI? Daniel might be using that for a higher resolution or refresh rate on an older monitor.
Dual-link DVI is even more sensitive. Because it uses more pins and higher frequencies to get more data across, the reliable limit stays around 5 meters. If he needs to go further with DVI, he is better off using a DVI to HDMI adapter and then using a long HDMI cable, because the HDMI ecosystem has better long-distance solutions.
Okay, so let us move to HDMI then. Most people think HDMI can go forever, but I have tried those 20-foot cables from the bargain bin, and they are hit or miss. What is the actual standard?
It depends entirely on the version of HDMI and the resolution you are pushing. If you are just doing 1080p at 60 Hz, a good passive HDMI cable can go up to 15 meters, which is about 50 feet. That is actually quite a long run. But, and this is a big but, if Daniel is running a 4K monitor at 60 Hz, or heaven forbid a high refresh rate gaming monitor at 4K, that distance drops off a cliff.
Because of the bandwidth, right? HDMI 2.1 needs 48 gigabits per second.
Exactly. For HDMI 2.1, a passive cable is usually maxed out at about 3 meters. Anything longer and you will get signal dropouts or the screen will just stay black. For Daniel's 3-monitor setup, if he is using modern high-resolution screens, he is going to need active optical cables, or AOC, for the HDMI runs too.
We actually touched on some of the complexities of driving multiple high-resolution displays in episode 221, when we were looking at those massive mission control style setups. One thing I remember from that discussion was that the more screens you add, the more you have to worry about the total signal load and interference if all those cables are bundled together.
That is a great point, Corn. If Daniel runs 3 or 4 long cables through a single hole in the wall, they can actually interfere with each other if they are not shielded properly. But the AOC cables I mentioned are great for this because fiber optics are immune to electromagnetic interference. He could bundle 10 of them together and they would not bother each other at all.
So for the displays, the takeaway is that old tech like DVI is actually okay for medium distances at low resolution, but for the modern stuff, he is looking at active or optical cables if he wants to go beyond 10 feet. Now, what about the third monitor? He mentioned USB-C to USB-C monitor connections. This is becoming the standard for laptops and some high-end desktops. Can you run a monitor over a long USB-C cable?
This is where it gets really tricky and where most people get frustrated. When you run a monitor over USB-C, you are usually using something called DisplayPort Alt Mode. This means the USB-C cable is carrying both high-speed data for any USB ports on the monitor and the video signal itself.
And often power too, right? Power delivery to charge a laptop?
Exactly. Doing all 3 of those things at once over a long distance is incredibly difficult. For a passive USB-C cable that supports video and high-speed data, you are generally limited to 1 or maybe 2 meters. If you find a 5-meter USB-C cable that claims to do it all for $20, it is probably lying or it will only work at very low resolutions.
So if he wants his third monitor to be connected via USB-C from a PC in another room, he is essentially looking at an active Thunderbolt cable, or a very specific active USB-C cable.
Yes, and active Thunderbolt 4 cables are fantastic, but they are expensive and usually max out at about 2 meters for copper. If he needs to go further, there are optical Thunderbolt cables, but they are very pricey and they usually do not carry power. So he could get the video and data to the monitor 30 meters away, but he would still need to plug the monitor into its own power outlet. It would not be a single cable solution for power.
Which leads us perfectly into his next question. The power cables. He mentioned the IEC C13 to C14 cables. He called them Mickey Mouse cables, though I think he might be mixing them up with the smaller C5 connectors that actually look like Mickey Mouse ears. The C13 is the standard trapezoidal one you see on the back of every desktop power supply.
Right? The C13 is the female end that goes into the computer, and the C14 is the male end. If he is using a UPS, an uninterruptible power supply, he might be using a C13 to C14 extension to get power from the UPS to the computer.
So how long can those be? Can he just buy a 50-foot power extension cord and call it a day?
Technically you can, but you have to be very careful about the gauge of the wire. This is something people often overlook. In the United States and other regions with lower voltage like 110 or 120 volts, the current is higher for the same amount of power. If you have a long, thin wire, you get a voltage drop. The wire itself has resistance, and that resistance turns some of that electricity into heat.
And if the voltage drops too much, the power supply in the computer has to work harder to compensate, or it might just shut down if it hits an undervoltage protection limit.
Exactly. For a standard desktop PC that might pull 500 to 800 watts under load, you really do not want to go beyond maybe 15 or 20 feet with a standard 18-gauge power cord. If Daniel wants to go further, he needs to look for a 14-gauge or even a 12-gauge cord. The lower the gauge number, the thicker the wire and the less resistance it has.
It is funny how we worry so much about the data cables, But the power cable is arguably the most dangerous if you get it wrong. A hot power cable in a wall is a fire hazard.
It really is. And since Daniel's here in Jerusalem with us, we are on 230 volts. That actually helps a bit because higher voltage means lower current for the same wattage, which results in less voltage drop over distance. But the rule of thumb remains, keep power cables as short as possible, and if you must go long, go thick.
So let us synthesize this for him. If he is setting up this remote workstation, he is looking at a bundle of cables. Let us say he wants the computer 10 meters away, which is about 33 feet. That is a pretty standard distance for going to an adjacent room or a closet.
For 10 meters, here is the shopping list. For the USB 3.0 peripherals, he needs an active extension cable or a fiber optic USB cable. For the HDMI monitor, he definitely needs an active optical cable. For the DVI monitor, he should probably get a DVI to HDMI adapter and run a second optical HDMI cable. For the USB-C monitor, he is likely going to have to give up on the single cable dream and run a separate display cable and a separate USB data cable to the monitor's hub.
And for the power, he should probably keep the UPS near the computer itself, rather than near the desk, and just run a high-quality, thick-gauge extension cord if he absolutely has to. But ideally, the computer and its power source should stay together.
I agree. It is much better to have the long runs be data and video rather than high current power. One thing Daniel mentioned at the end of his prompt was, wake on LAN and shut on LAN. This is a brilliant addition to a remote setup.
Yeah, explain that for those who might not have heard of it. If the computer is in another room, how do you even turn it on?
Wake on LAN is a protocol that allows a computer to be turned on by a network message. So Daniel could actually use his phone or a small button on his desk that is connected to the network to send a magic packet to the PC in the other room. It tells the motherboard to wake up. It is way more elegant than running a separate long wire just for the power button, although you can actually do that too with a simple 2-lead wire.
I have seen those remote power buttons. They are just a physical switch on a long cord that plugs into the power jumper on the motherboard. It is a bit low-tech, but it works every time. No magic packets required.
True, but Daniel is a techie. He will probably go for the network solution. Now, there is one more thing we should mention for anyone thinking about this kind of setup, and that is latency. Even though light travels fast, active electronics and signal conversion can add a tiny bit of delay.
Is it noticeable? We're talking about milliseconds, right?
For most people, no. But if you are a competitive gamer or doing high-end video editing where you need frame-perfect precision, you might feel a tiny bit of lag if you are using lower-quality active converters. This is why we always recommend the fiber-optic versions for video. They have almost zero added latency compared to some of the cheaper electronic repeaters that have to process the signal.
That makes sense. It is all about maintaining that high-speed highway without any toll booths along the way. I am curious, Herman. Do you think we will ever get to a point where we do not need these physical cables? Like, could Daniel do this whole thing wirelessly in 2026?
We are getting closer, but we are not there yet for a primary workstation. Technologies like Wi-Fi 7 have incredible bandwidth, but they still struggle with the consistency needed for a display. If a single packet drops on your video stream, the screen flickers. That is fine for a movie, but it is infuriating when you are trying to work. We talked about some of the future-proofing for home networks in episode 169, and even then, we concluded that for high bandwidth, low latency stuff, copper or fiber is still king.
It always comes back to the physical connection. There's just no substitute for a dedicated pipe for your data. So, looking at Daniel's specific setup, he has this optical drive. Most people might say, why even bother with a physical drive in this day and age? But if he is doing high-quality archival work or listening to lossless audio from his old CD collection, that USB 3.0 connection really matters.
It does. And those optical drives are surprisingly sensitive to power fluctuations too. If he uses a long, cheap USB cable, the drive might have enough power to spin up, but then fail when it tries to move the laser assembly. That is another reason to go with an active cable that has its own power injection if possible.
This whole discussion really highlights how much we take for granted when our computer is sitting right under our desk. Everything is designed for that 3 to 6 foot range. Once you step outside that bubble, you are essentially entering the world of industrial AV or professional server room management.
It is a different world for sure. but it is a fun one to play in. There is a certain magic to sitting at a desk that is completely silent and cool, knowing there is a powerful machine doing all the heavy lifting in a different room. It feels like the future.
It definitely does. And for Daniel, it is about creating that perfect environment in our house. I think he can do it, but he just needs to be prepared for the cable budget to be a bit higher than he initially thought. Those optical cables are not cheap.
No, they are not, but they are a one-time investment. A good fiber-optic HDMI cable will last him through several computer upgrades.
That is a good way to look at it. It is infrastructure, not just an accessory. Well, I think we have covered the bases for him. USB 3 has a 3-meter passive limit, HDMI and DVI are around 5 to 15 meters depending on resolution, and USB-C is the shortest of all at about 1 meter for full speed. Anything beyond that, and you are looking at active or optical solutions.
And do not forget the power cables. Keep them thick and keep the runs as short as you can. Safety first, even in a high-tech house.
Exactly. Well, this has been a great deep dive. It is one of those topics that seems simple until you actually try to plug everything in and nothing works. Hopefully, this saves Daniel and our listeners some frustration.
I hope so too. It is all about knowing the limits of your gear before you start drilling holes in the walls.
Definitely. And hey, if you are listening and you have done a remote PC setup like this, we would love to hear how you handled the cable management and if you found any specific brands that worked well for those long runs. You can always reach out to us through the contact form at myweirdprompts.com.
And if you found this episode helpful, or if you have been enjoying the show for a while, we would really appreciate it if you could leave us a review on your podcast app or on Spotify. It genuinely helps other curious people find the show.
It really does. We love seeing the community grow and hearing your thoughts on these deep dives. You can find all our past episodes, including the ones we mentioned today about USB-C and multi-monitor setups, over at myweirdprompts.com. We have a full archive there with an RSS feed for you to subscribe to.
This has been episode 440 of My Weird Prompts. Thanks for joining us in the Jerusalem studio today.
Thanks, everyone. We will see you in the next one.
Until next time.
So, Herman, before we wrap up, I just had one more thought about Daniel's setup. If he's putting the computer in a different room, what about the audio? He didn't mention it in the prompt, but he's got those nice studio monitors on his desk.
Oh, that is a classic pitfall. If he is using a USB audio interface, he is back to the USB distance limits we discussed. If he is running analog cables like TRS or XLR, he can actually go quite far, especially with balanced XLR cables. Those are designed for long runs in concert halls. But if he is just using a standard 3.5mm headphone jack, he is going to pick up a lot of electrical noise over a 30-foot run.
Right. He might start hearing the refrigerator or the microwave through his speakers.
Exactly. So the best bet for him would be to keep the audio interface at the desk connected via that long fiber optic USB cable we talked about. That way, the digital to analog conversion happens right where he is sitting, and the analog cables to the speakers stay short.
It always comes back to that one high-speed data pipe. If you can get a reliable USB or Thunderbolt connection to the desk, you can put everything else on a hub.
Precisely. The hub is the key. It simplifies the whole thing from a bundle of 10 cables down to maybe just 2 or 3 high-quality ones.
It is a bit of a puzzle, but a satisfying one to solve. I think Daniel's going to be busy this weekend.
Better him than us. I am happy just talking about it.
Fair enough. Well, thanks for the expertise, Herman Poppleberry.
Always a pleasure, Corn.
All right, that really is it for today. Thanks for listening to My Weird Prompts. We'll be back soon with another deep dive into whatever strange or wonderful topic Daniel or our listeners throw at us next.
See you then.
Bye for now.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.